Alright guys, good morning. This is lesson 8.3, it's acids and bases. So take a second, get yourself set up, and then we will get started. Okay, you have obviously heard of acids and bases, but you may not have heard of the pH scale. You probably have, but some of you may not have. So the pH scale is a way to measure how acidic or how basic something is. Let me move myself here so you can see it. Anything that's acidic has a pH that's closer to 0, and anything that's basic has a pH that's closer to 14. Okay, we tend to eat things that fall right in here. We actually eat a lot of very acidic food. Right? Notice how all of these things are, here are food. And we don't have anything that's food down here. Okay? Distilled water should be right at 7. That's what we consider neutral. Human blood is a little bit basic. Milk is a little bit acidic. If ever you have stomach acid problems, what you'll do is you'll take some medicine that is basic that falls right about here in terms of acids and bases. Notice sodium bicarbonate right here. This is baking soda. That's a little bit basic. All right. Let's talk about acids and bases on the pH scale. Again, anything that has a pH between 0 and 7 or a lower pH value is more acidic. Anything that is between 7 and 14 is basic. The higher the pH value, the more basic. So the further you get away from 7, the stronger you are as either an acid or a base. Now the way to remember which side is acidic and which side is basic is just to think about A comes before B, 0 comes before 14. Right, so the closer you are to 0, the closer you are to A, that's an acid. The closer you are to 14, the closer you are to B, that's a base. Distilled water, again, distilled water has a pH of 7 and is considered neutral. So there are several definitions of acids and bases, but this is the only one that you need to know. An acid is a substance that increases the concentration of hydronium or H+. So hydronium is H3O+, or the H+ ion. In an aqueous solution, we learned about aqueous, that means dissolved in water. And a base is a substance that increases the concentration of hydroxide, which is the OH- ion. We will look at how do you determine if something is an acid or a base based off of its formula here in just a moment. Properties of acids. Some of these you should actually already know. So they produce H+, this is H3O+, this is hydronium, ions in water. The hydronium ion is what happens, it's what you get when this H+ attaches to a water molecule. That's what creating hydronium is. They taste sour, so if you think about lemons and oranges and grapefruit especially, they taste very sour. They do corrode metals, so battery acid, if you spill battery acid on your car, it can corrode the metal in your car. They are electrolytes, which means that they can conduct electricity in water. They react with bases to form a salt and water. This is always true. An acid and a base reaction always forms salt and water. Their pH is less than 7, and it turns litmus paper from blue to red. So litmus paper is an indicator that we use to determine if something is an acid or a base. We'll actually be using some litmus paper next week when we do a little lab. The properties of bases, they produce OH ions in water. This is called hydroxide. It's not listed on your list of common ions, so it is something that you have to memorize. They tend to taste bitter or chalky. So if you think about eating Tums, Tums are very chalky. That would be a good example. They feel soapy or slippery. So dish soap is a base, and that's one of the reasons why it feels slippery. That's a property of a base. They react with acid to form a salt in the water. Their pH is greater than 7, and they turn red litmus paper to blue. And you can think about that remembering basic blue. So identifying acids and bases by formula. There are questions that will ask you to identify whether or not a chemical is an acid or a base just by looking at the chemical. The biggest giveaway here is that every one of these chemicals start with a hydrogen. Okay, when you begin with a hydrogen, more often than not, that chemical is an acid. Bases end with an OH. This is where you're going to form your water. When it talks about forming a salt in a water, is this H plus this OH gives you H2O to form a water. The exception to the OH at the end is ammonia, which is also a base. It's just a very common household base. So you will have to recognize that this is a base and that it's called ammonia. If we look at the names of acids, they're a little bit different than how we would name our bases. So this is hydrobromic acid, this is carbonic acid, and sulfurous acid. Okay, the carbonic acid, notice this is a carbonate, right? This is a sulfite. Naming bases is a little bit easier. This is, in this case, you just, the same way that we were naming ionic compounds, you name the cation and then you name the anion. So sodium hydroxide, magnesium hydroxide. If you think about it, you should have already jumped to this. This is aluminum hydroxide. Very simple. Okay? When you see that hydroxide, that's an indication to you that you're dealing with a base. So now we're going to test your knowledge. A solution with a pH of 4.5 would best be classified as a what? An acid or a base? A solution with a pH of 8.9 would best be classified as a what? An acid or a base? Take a minute, think about it. HNO3 would best be classified as an acid or a base? Okay, you should have gotten, oh no, one more. Magnesium hydroxide is best classified as an acid or a base. You should have gotten that a pH less than 4.5 would be an acid because it's below 7. A solution with a pH of 8.9 would best be classified as a base because its pH is above 7. HNO3 is best classified as an acid because it starts with an H. And MgOH2 is best classified as a base because it ends, or this should say ends, it ends with an OH. Okay, indicators. So we looked at indicators for a second there when we were talking about properties of acids and bases. An indicator is a substance that changes color based on the pH. So in the presence of an acid or base. It's a very quick and qualitative way to determine if something is acidic or basic. So acids turn blue litmus paper to red litmus paper. And the little chant is blue to red acid. Bases turn red litmus paper blue. So you get basic blue. That's the way that you can remember it. Now, notice here, it's not the color of paper that you start with, it's the color that the paper turns to, which determines whether or not it's acidic or basic. The other major indicator that we use is an indicator called phenolphthalein. Phenolphthalein is just a chemical, it's a clear chemical that you drop in the liquids, whatever your solution is. And if it's acidic, it remains colorless, but if it's basic, it turns pink. So here's a picture of litmus paper. Notice you got that blue to red. It's an acid. It has turned the blue litmus paper red. And for a base, it has turned the red litmus paper blue. In phenolphthalein, this is the bright pink color that we were talking about. Acids will remain colorless. Notice they put the indicator right on or this is where they're starting to add a basic solution right on top. And then if it's the moment it becomes basic, it'll turn pink. Okay, here, do yourself a little check. Is the solution in the dish an acid or a base? How do you know? Take a moment and think about it. Alright, you should have said that it was an acid because you're taking your blue litmus paper and you're turning it red. Is the solution in the Erlenmeyer flask an acid or a base? How do you know? You should say that it's a base because it's turning phenolphthalein pink. Phenolphthalein is pink in bases. Good. Here's another check. Phenolphthalein is added to a clear solution and it remains clear. What conclusions can we draw? Think about it. Also think about this. A blue litmus strip is placed in a clear solution and the strip turns red. What conclusions can we draw? Alright, in our first one here, we've taken our phenolphthalein, we've added it to a clear solution. It's still clear. That should be an indication to us that the solution is acidic because phenolphthalein will remain clear in an acidic solution. For the second one, a blue litmus paper is placed in a clear solution and the strip turns red. What conclusions can we make? The solution is acidic here as well. Remember, blue to red is acid. Alright, here's an example of a question that you will see. The chart shows an acid-base testing of 4 samples. Based on the chart, which samples or sample are acids? So here are the 2 sets of indicators that they use. Here's phenolphthalein, which we just talked about in litmus paper. Notice as we go through, phenolphthalein goes from pink to colorless. Colorless is an acid. Alright, so if I'm changing from pink to colorless, I see an acid right here. In sample 2, I use phenolphthalein again, and I go from colorless to pink. Pink indicates to me that it's a base, so sample 2 is a base. Sample 3, we're using litmus paper. I go from blue to red. If we remember the chant, blue to red is acid. Then I know that this sample right here, sample 3, is also an acid. And let's look at sample 4. Sample 4 is also using litmus paper, and I'm turning from red to blue. And if we think about blue basic, we know that this sample right here, sample 4, is a base. So let's go back to the question again. Based on the chart, which sample or samples are acids? We know that it's sample 1 and sample 3. So my answer choice is C. Alright guys, that's it. If you finish early, please go to Achieve 3000 and do an article on Achieve. I will see you all on Monday.